So we're starting normal distributions. We're kind of easing our way into it. So I'll be upfront about this. I'm going to show you, and this happens in math lessons sometimes, where I'm going to show you kind of a process and a way to do something, but it's not like the ideal way, and there's a much faster way. But I'm showing you this so you understand the concept of what we're doing, and then Monday I'm going to be like, okay, now just do this. And it's faster and easier. But if I just showed you the thing that's faster and easier, you wouldn't know what you're doing. Does that make sense? You wouldn't understand what you're finding. So we're starting with the empirical rule. It's for normal distributions. What? Empirical. What? Yeah. So normal distribution is like the bell curve, where you got a mean. So that's mu. It's like the Greek letter U. It's actually the Greek letter M, I think. So it's kind of like a diagonal M or like a U with a tail. It's mu. That's how you say it. And that's the middle of your distribution. That's the mean. And then we're going to start talking about standard deviation. So standard deviation has to do with how spread out things are. So a very large standard deviation would be something that's really spread out. If you think of someone that you know that is really moody, you never know, they could come in and be the most depressed person one day and the next day they're on top of the world. They would have a large standard deviation in their moods. Some people might say I'm like that actually. I don't know if I've exposed that in this hour, but I can be like that. Some people are just always the same. They're almost robotic. I'm not fluctuating too high or too low. That would be a low standard deviation. So the symbol for standard deviation is if I go one standard deviation this way, and one standard deviation this way, this is minus one standard deviation. This is plus one standard deviation. We'll get way more into standard deviation as we go. Right now, I'm just trying to. So, what are you looking at? I didn't write it. It's a 1 minus 1, and then it's like an O with a hat on it, kind of. Yeah, it's like an O with a baseball cap.
Just like the symbol for standard deviation.
That's the symbol for standard deviation. So mu equals mean. That equals standard deviation. Sigma. So what the empirical rule says, and it's an estimate, but we'll get more precise as we learn more about it, is 68% of the data in the normal distribution is within one standard deviation of the mean. I'm going to combine this under one chart in a little bit, but right now I'm going to make 3 separate charts. So the entire thing is 100%. 100% of the data is in this curve somewhere. So 68% of it is within one standard deviation each way. So for example, if I said the average SAT score was 500 and the standard deviation was 50, you'd put 500 here. This would be 450. This would be 550, and 68% of the SAT scores would be between 450 and 550. That's the problems we'll start doing a little bit after I get through the notes. If I went with the mean, and I go 2 standard deviations each way, approximately 95% of the data is within 2 standard deviations. So most of the data clusters in the middle, that's why there's that big peak there at the top of the hill, and as you get further away from the mean, there's less and less data. The average SAT score is 1,000. There's not a lot of people that get 1,500, 1,600. There's not a lot of people that get 500, 600. mostly you're in the middle. And then the third, if I go 3 standard deviations each way, 1, 2, 3 this way, and 3 this way, 99.7% of the data is within 3 standard deviations of the mean. There's not really a pattern. I mean, like there's a reason for it, but there's not a pattern. That's it. We're done. We're not doing like 4, 5, 6. Like it's just those 3 numbers. So if you just remember 68, 95, 99.7. Those are the 3 numbers. And we're going to break it down a little bit further too in a second. And we'll start doing examples, which will help it make more sense too. So I'm going to turn my paper sideways and make like a big. Is anybody still writing this? We're good. I'm going to turn my paper sideways and make a big one. You might want to watch what I'm doing before you write. Kind of get an overview before you put it on your paper. That was a freaking good one. Look at that. That's beautiful. Alright, so I'm going to put the mean in the middle. I'm going to go -1 standard deviation plus 1 standard deviation. -2 standard deviations plus 2 standard deviations. -3 standard deviations plus 3 standard deviations. And then I'm going to draw like a dotted line up from each one of those. So there's what I want to draw. So I'll give you a second to try to make it as good as mine, but I mean, you have no chance really. Look at that thing. It is funny, like the first time you guys typed out normal curves, and no offense, but they're usually awful. You what? That's harder than a normal curve? Can you guys see that? Yeah, me too. Like I can barely see it. You could sit like not in the farthest spot in the room away from the board. My bad, but I'm not gonna do anything about it.
Okay, in English, I sit in the front and I still can't see the freaking lecture.
Wait, you can't see this either?
No, I can't. What?
Don't you just listen?
Yeah, but if I want to write something down, I literally cannot read the board.
So you
No,
guys see
no,
this
this
either?
is good. No, this is fine. It's just really small.
I think you need to come to Bob Optional. Your eyes checked.
I know. No, I do. I haven't.
Do you get a kickback for that?
Like all of it is in the textbook.
No, I know.
You just don't want to write it down in the textbook.
Well, sometimes he puts stuff on there where it's more emphasized.
But he's just like putting up things that are already typed and it's small.
Yeah.
Yeah, like.
It's like a pre-set lecture, like
Yeah,
PowerPoint or
it's just
something?
knowledge points right there.
okay,
Just add
The notes are
stuff
the
to
same
it.
every single year.
right.
So.
I mean, so am I.
I'm about to ask him to add the Schoology.
It didn't really.
He should, yeah.
I mean, it didn't really help. Or,
Yeah,
I just listened and it was.
All right, we good? So I want to put percentages in each of these little sections. So I told you 68% of the data is within 1 standard deviation, right? It's symmetric. So if there's 68% here and here, couldn't I say there's 34% in this section and 34% in this section,
Yes.
right? Then I want to keep doing that thought process and finish this. And in a second, I'm going to have you guys like turn to a new page and try to recreate this without looking. See if you can like think through the same process. So within 2 standard deviations is 95%, right? But how much percent is already gone? How much did I use already? 68. So if you do that subtraction, you got 27% left to split into these two sections. So what are both of these? 13.5. Carry it to the next level. So within 3 standard deviations is 99.7. Well, I already used within 2 standard deviations. The 1% is within 2 standard deviations. 95. So how much do I have left to get to 3 standard deviations? 4.7. So 4.7 is going to get split evenly among these two. 2.35% there. 2.35% there. And then for the last part, so if you're like above 3 standard deviations away from the mean, you're in really rare territory. This would be like a 1600 on the SAT. This would be like a 35, or maybe 1550, 1600. This would be like a 36 on the ACT, maybe 35. This is like if the IQ average is 100, this is probably like 150. This is like the people that get into medicine, like the geniuses. So how much percent have I used so far? 99.7, right? And how much is the whole thing? 100. So I've got 0.3% left. So only 0.15% are going to be out there. So make sure you realize that's 0.15%, not like 15%. So that's like 0.0015, really. What's that?
I wonder how it feels to be in a band. Except for
So like, you might be out there in certain things. Like Mr. Packard is here for male heights. No, I don't know.
I think he's no.
I don't know if he's that far.
It's probably like 2.35%.
I might be like,
Oh, yeah.
I'm up here for heights. No, I'm probably like in this range. I don't think I'm that far. This would be like 7 foot tall or something.
Yeah.
Average height.
Shaquille O'Neal's like
Average male
Yeah.
height might be like 5'10", maybe.
Alright, so I want you to turn the page, flip it over, put that away, and see if you can do that again. And I'm going to write it on the board so we have it up to do some problems with, but I wanted to make sure this was on the video.
brag that I drew a pretty good move.
Yeah? You think you got it? Feeling yourself? Not bad. Not bad.
This one's pretty bad.
Wait, I want to add something too, because this will help as we're going forward. Put, like way over here on the right, put a positive infinity sign. It's just a sideways 8. Everybody relax.
I don't draw it like that, but sideways because I can't.
Turn your paper sideways and draw that 8 the way you do. And then on the other side, put negative infinity.
Is it possible to have infinity IQ?
I don't know. I've had some people in integrated math.
I always wanted to take an IQ test to like see
I don't want to take it.
where I would be.
It's such a,
Such a garbage measurement.
yeah, like there's so many different ways of intelligence.
I'm gonna
Like it
take
doesn't measure
it.
artistic ability, musical ability, social ability, athletic ability. Like there's so many. Like my social ability would be in the negative infinity area.
Negative.
So, so if you get stuck, just cheat. Just cheat off your notes, but try not to. It's not perfect, but it's not bad. flexing your drawing of your. I don't know the numbers, but look how good my. Blind people in the back, is this big enough for you? Who said that? Are you serious?
I can see it.
He said, "Are you serious?"
Oh, I don't know. Don't worry about this yet. Just put it up for
This
Yeah.
little
you.
you.
Yep.
Is that the me or the
Me.
me?
I wrote it up.
Yeah, no. But
Like, you can't see that part.
it's like it's confusing me because it's in the middle.
So, if it's symmetric, because it's symmetric, the mean of the pull, so the mean of the median are actually the same in this because it's not skewed. There's no pull one way or the other. But when we talk about normal distributions, we don't really worry. We don't talk about the median. We talk about the mean, even though they're the same. Yeah.
No, just say I just crushed it. I actually.
So you can check your own, right? This is 34, 34, 13.5, 13.5, 2.35, 2.35, and then 0.15. And those are percents, remember. And then let's put the negative infinity over there, and then infinity over there. That'll make sense why we're doing that in a couple days. But for now, I just want you to get in that habit, I guess. Yeah.
If we make these for like a problem, do we need to have contents for these too?
Yeah, but you wouldn't really have to, because remember, this is like the general understanding, but then in a couple days, I'm going to show you, like, okay, screw this, there's a faster way. So you probably won't have to make. But let me just say that. Anytime you make a graph or a chart, like, is that fair enough? Okay. So. I'm going to print this. It makes it a lot easier. So give me a second here. In my head, it went differently. Sorry. Not that you're worried about like use of class time. Be back in a minute.
That's what I said.
Hey, Mom, I do your hands back up. I need to find I said
I did it, but I screwed myself. Did it really? And then she's like, first of all, she's graded. And so she was crazy about before it has to be on time. Like, bro, you still have not raised it from the second week. No, I do.
So basically, they're saying like they had was like 3 grams too much. So if each one is 3 grams too much, then the median is going to be affected. It's going to be 3 grams.
I think it was so.
Actually, it's not going to
It was either that
the mean will be affected. It's going to be greater than it'll be
last year's maybe.
like imagine like
Actually, the last one. I couldn't tell you
divided by 3.
Yeah, typically it's 4 or 5.
But once you subtract these additional, you get the minus
Yeah.
the test.
Oh,
So that's what we're talking about. If they all have like, if they all were just affected by like some like set thing, like additional thing.
I forgot to change the font before I printed it, so it's like senior citizen level font.
Sarah, right?
Yeah.
Could she come in here and just like chill? She has nowhere to go. Really?
I mean, you're not looking at your phone to like communicate with her though, right?
No.
You never. Put that away real quick after you text her, please.
Okay.
Thanks, fam. Alright, so these are the types of problems that you'll be asked to do. And for right now, we're just estimating these answers because this empirical rule is an estimate. So, for example, it's not really 68%. I think it's like 67.98 or something. It's really close, but it's not perfect. So, let's draw this at the bottom because there is some space down there. So, the first thing says, IQ scores are normally distributed with a mean of 100 and a standard deviation of 10. Sketch the distribution showing 3 standard deviations each way. So, you can draw your normal curve. Mean is 100. And then I'm going to go, okay, well, I want to go minus 1 standard deviation. Well, what IQ score would that be? 90. Minus 2 standard deviations, 80. Minus 3, 7. Plus 1, 110. You guys with me? And then I'm going to put those percentages on there too. Like the same thing we have on the board, the same thing we just did. I'm just going to, I don't even have to draw the dotted line necessarily. I'm just going to, it's going to make my doing the problem easier if you have these percents here. I'll put the lines anyways. Then we're just going to use that to answer all the questions that are above. Wait, does she like never have a, what does she have this on?
She's usually at consortium, but they don't have it today, so she's.
Oh, so that's no school then. Yeah, because my kids are at school.
Yeah, I remember
wait, why did you say it?
it's like 2.5 hours.
Wait,
Is that good?
why don't they have school today?
Because why?
I think it's because like the place that they usually go, they don't.
No, why does Celine not have school?
I don't.
Yeah, they just get like a random fall break. Just, yeah. They started 4 days earlier, right? They started a week before we did, so they get like these random days throughout.
They did that last year. That's like college. When I was in consortium last year, they started.
Yeah.
It was every third week of the month. They had a half day either on Monday or Friday. Wow.
Oh, really? Plus they're trimesters, so they get like a records day. At the end of first try, at the end of second try, so there's two other days in there.
Yeah, Bounce kids goes there. And he was talking
Yeah,
about
my kids go there. We good here? You got it drawn? Sansone, you still drawing?
practicing my appendicitis.
You're practicing your normal curve?
No.
Hey, how's it going, Sarah?
Science.
Okay. So, what percent of scores are above 80? So you're literally just looking at this chart and adding scores together. So what percent of scores are above 80? So there's 2 ways you can do this. And I would choose the shorter one, but it's up to you. Percent of scores above 80 would be 13.5 plus 34 plus 34 plus 13.5 plus 2.35 plus 0.15. Or, how else could you do it? 100 minus these two, right? Wouldn't that be a lot easier? I mean, it's shorter, right? So what do these two add up to? 2.5. So 100 minus 2.5. This would be 97.5%. So what the infinity is for is when you go to type these into your calculator, your calculator wants to know like between what and what. So you'll put like between this and infinity. Like that's how the calculator views it. So you can't just say above 80, you have to say like between 80 and infinity. So that's why I put those signs there. Because people get confused like where the positive and negative infinities are sometimes. So what percent are between 90 and 120? So I mean you literally just add. So 34 plus 34, so we're at 68, plus 13.5. So we are at 81.5%. Does that make sense what I'm doing? Questions on it? Alright, finish it. So I'll talk through these in a second, but there's the answers. If you don't want to look at, don't look. Spoiler alert, but there they are. Okay.
Yeah, I'm surprised you said yes. I thought you said no.
Well, I'm a little annoyed at everybody that check my folder, but that's not good enough. But,
Wait, I'll get it.
yeah, take care of that.
3%.
So no, so that's how many. So find the percentage and then
Okay.
you
Yeah. I didn't know if that was like used or.
yeah, it's not like you did. It's not like you did.
Yeah.
So make sure you realize on 7 and 8 it says how many. So take your percentage and multiply by like the number there are. So this is the size of money.
Yes.
Right?
It's like the only option.
Yeah, exactly. Yeah. Okay.
Sure.
I put it in first hours. So above 110, you just add up these percents. That'd be 16. And then you use 60% off. So that's
I was looking at it. They have one time.
I do about it.
so it's like 110 on everything that's this side. Like through infinity is kind of what
I
we're
was
going to start
looking
thinking
at it.
about. Does that make sense though?
Yeah. I did that one. I did that process.
Yeah, you did 8. Yeah. Okay. Oh, did you think I thought it was your phone? Is that weird?
Yeah, I was.
Oh, is it your phone?
It was my calculator.
Don't you have an actual calculator though?
All the way
It has one battery.
What?
Do you know that it needs 4? So that might be why it's not working. Alright, so middle 68%. So the 68% is here, so you're going to say between 90 and 110. Number 4, the middle 95%. That's within 2 standard deviations, so that's between 80 and 120. 4. What IQ scores are not between 80 and 120, so you can do this 2 ways. You can find what is between 80 and 120 and then do what? Subtract it from 100, or you could just start adding up these, these 4 little sections on the side. That'd be 5%. What percent are above 130 is this 0.15% over here. And then just make sure on these you see that it says how many. So above 110 would be 16%. And it's really tempting to put 16%. And on the AP test, they probably make one of their multiple choice answers 16%. But it says how many, so you gotta do 16% of the 1,000. So it'd be 160 people. And the same with number 8. So within 1 standard deviation, the mean is 68% of the people. You have 3,000 people. So I got this by doing 0.68 times 3,000. Those good? Let me add all those. Alright. Let me give you a packet, but I just want you to do the first page. Just do the front. Just do the front. Just do the front. There you go.
Don't forget.
You do? Just the front. I've said it a lot, so if you do the whole thing, that's on you. That's your fault. My goodness gracious, are you serious?